see what we've got. Since the price of a pizza is $5.95 plus 75 cents per added topping, find the number of additional toppings for the cost of $8.95 through an equation. All right, so we're starting with a $5.95 pizza, but we're going to put more toppings on it. They cost 75 cents each, and our final cost is going to be $8.95. All right, so, and it says through an equation. So guess what? We're going to play algebra here. Let's take a look at this problem, see what's going to go on with it. All right, got a little smaller font here today because we had a lot of words going on. So we're trying to squeeze them all in there with that and leave me a little bit of room to work with it. So let's take a few pointers here. We start with $5.95. Price of a pizza is $5.95. But we're going to add 75 cents per additional topping. I don't know what we've got on there right now. May have just cheese, all right? Going to make you hungry, all right, folks? It's just going to be a hungry night here, it sounds like. But what we want to do is let n represent that number of additional toppings. It's very similar to the problem we had last night on our problem of the day, and hopefully you're checking those out also on Facebook here. Number of additional toppings. So what do we do with them? Well, we charge 75 cents each, all right? So we started with $5.95. We'll use the decimal form because that's what they gave us. And we're going to add on 75 cents. Let's try to see if I can get that right. 75 cents per topping and wind up with a pizza that cost us $8.95. All right, and that probably is before tax. That we'll add a little tax on there, but we're not worrying about that right now. We're wanting to see what's that basically cost going to be. So I first look at the thing and I'm saying, okay, I've got this 75 cents that needs to take a hike. I've also got this $5.95 that needs to move, so I can get n by itself. And over here I've got $8.95. Now, first thing I want to use on this, make comment is, decimals are not a problem, all right? Don't worry about it. Don't worry about them. You're just going to subtract and add them like you normally would do, or divide, whatever you're needing to do, all right? So just hang in on that, all right? Don't let it bother you that we have a bunch of decimals here. Because I know a lot of times we're always, oh, if it's 4 plus 3x equals 10 or something like that, I can do that real easy. Yeah, well, you can, and you can do this real easily too, all right? So first let's go with it. Let's lose the $5.95 here. And if we do it to the left, we've got to do it to the right. So let's subtract off both sides. And all of a sudden, this problem looks a lot easier, okay? Because now we have, if I'll drop my lower third out of there, ladies and gentlemen, there we go. We're going to have 75 cents per n. We're going to have 0.75 n, or 75 hundredths times n, however you want to look at that, equaling, ooh, that's going to give me $3. So that's not so bad. So at this point, I'm going to be dividing, it looks like, $3 by 75 cents and see how many ways that will go. And what actually happens when I do the division, and I can do that on the calculator, we can do that on the calculator, it will give us n equals, drum roll time, give you 4. That is 4 additional toppings. Now let's check that arithmetic. Some of you are going like, calculator, are we sure? Let's go for it real quick here. Hit it. We're going to take 3. And we don't have to put 0.0 and all that good stuff because that's understood that 3 is just that. And you could add a decimal and a bunch of zeros and you still have 3. So let's go ahead and do that and divide by 75 cents, which in this case is 75 hundredths. Look in our decimal. And what it does, it gives it 4. And that's exactly what we said. We would have 4 additional toppings to go there. And you know what? That's pretty much the answer to the question, answer to your thing. Let's go back and check, make sure it works in sense of the problem, all right? If we have, here we go, 4 of these, and remember that's going to cost 75 times 4, which is $3, and we add it to our $5.95, we are back at $8.95. And again, a lot of you said, I could have done it without the equation. Good, because that's the process. It's an algebraic process you're thinking through. And this is just a language. This is how you would translate, how you'd write it with a little bit of flow, a little bit of pretty language, and a lot of nice looking variables, stuff there. In this case, we have 1, which is n. But the thing is, it's the same story. You're still doing subtraction, okay, which got you $3. You're still dividing, and you got 4 from dividing it out. So it's just just putting it into a nice little language and flowing, all right? And it looks good. It just looks good, all right?